Okay. So we are going to do our answer submission page 2 by video today. So follow along with this and get your answer submission page 2 submitted for your free 100. All right, this says proportional relationship. If it's proportional, I know that it's going to go through the origin. It's going to go through 0, 0. So I'm looking at all of these graphs and I see that this line does go through the origin. This one does not. There's the origin. This one does not go through the origin. This one does not go through the origin. So the only one that goes through the origin is answer choice F. Okay, pretty simple. The next one. Oops. Oh, here we go. Number 2. This one says Julie made 25 international long-distance phone calls to London last month. The scatter plot below shows the length and cost of each phone call she made. So there's the intro, here's our graphic, and then it says the question, which conclusion is best supported by the scatter plot? When I look at this scatter plot, I'm looking at it, and there is no pattern, there's no definite trend going upwards or down. I'm looking at that, and I know that there's no association between the length of the call and the cost of the call. So I'm going to say, as the length of the call increases, the cost increases. No, that would look more like they're both increasing at the same time. That would look more like this. So that would be answer choice A. And then answer choice B says, as the length of the call increases, the cost of the call remains the same. So that would be more like a flat line, like this, right? 0 slope. This is increase, increase. And then answer choice C says, as the length of the call increases, the cost of the call decreases. So that would look something like this, where you can see the data going down like this. That is answer choice C. This flat line was B. And then the last one says there's no relationship, no association. So I'm going to go with D. There is no association between those two variables. All right, the next one. It says the scatter plot shows the average number of hours each of 13 people spends at work every week, and the average number of hours each of them spends on recreational activities every week. So here's the graphic, and then here's the question part. Based on the scatter plot, what's the best prediction of the average number of hours a person spends at work every week if that person spends an average of 10 hours on recreational activities? So 10 hours. This is where my hours are. So here's what I'm going to do. I'm going to go to 10 hours, and I'm going to draw a line at the 10 hours. So if you'll look at my answer choices, these spots right here, 35 and 30, are right here at 10 hours. So 85 hours of recreational activity. Oh, hold up. Hours of recreational activities every week. Not bad. Ignore that red line. We're going to do recreational activities right here, 10 hours of recreational. That's this line right here. Sorry. So, remember the finger test that I kept talking about? If you take this and just kind of draw a line through the data until you hit the orange line, and I'm hitting right here around the 70. Okay, so this is way too low. Way too low. Either 85 or 65. 85 is pretty high. That's going to be over here, and I'm not hitting that until somewhere down here. I think 65 is my best choice. And then if I look and I wanted to adjust my line a little bit, I actually made it kind of a little too high. I need to bring it down a little lower, and you'll see that you're going to get more between the 60 and the 70. So the answer would be D. It's just a finger test. That's all you're doing. Okay. So the next one says the manager of a restaurant recorded how many people were in different groups of customers and how much those groups spent on food and beverages. So here's the scatter plot. Based on the scatter plot, about how much money would a group of 10 people is on the bottom, be expected to spend on food and beverages. So 10 people is this line right here. So you're going to draw a line through the middle of your data until you hit the red line. So if I draw a line real quick, just a finger test through the middle of my data, I land right there, around between 120 and 140, probably around 130-ish. Okay, so I'm looking at my answer choices. Too much, too little. That's the one that comes closest to my finger test, between 120 and 140. Okay. All right, next, we got another scatter plot. It shows the number of hours that 12 people, here's the number of hours along the bottom, here's the number of people, spent learning to type on the average typing speed on the keyboard. Based on the scatter plot, what's the best prediction of a person's average typing speed in words per minute if the person has spent 70 hours? Hours are along the bottom. So this is 10, 20, 30, 40, 50, 60. So 70 is going to be out here somewhere, right? Kind of estimating. It's going to be out here. About, I'm going to draw this line right here. Okay, that's my 70 line. So then I'm going to draw a line through the middle of my data, and I'm hitting right about there. Just a finger test. That is around 90-ish. Okay. My answer choices. Looks like this is going to come closest to my estimate. So, yeah, right here between 80 and 90, about 85. That's the answer that comes closest to my estimate on my finger test. Okay. All right, number 6. Which scatter plot best suggests a linear relationship? Linear relationship means that you can draw a line basically through the middle of the data, a straight line. You see, this data kind of makes a curve. Yeah. This one also makes a curve. Here I can kind of draw a line through the middle of the data. And this is just sort of all over the place, right? So the one that is linear would be B. Okay. Number 7, which set of ordered pairs represents y as a function of x? If it is a function, that means x does not repeat. You'll remember Ms. Colvin's strategy was to circle all the x's. Remember a coordinate pair? X comma y. So I'm going to circle all of the x's, all of the first numbers. And if anything that I circled repeats, then it's not a function, but nothing repeats. So this is a function. That's the one. Let me show you why this is not a function. Do you see how those two lines repeat? Circle all the x's. See how the 3's repeat and the 4's repeat? Not a function. Circle all the x's. See how those 2's repeat and the 1's repeat? Not a function. The answer has to be A. Next. which statement describes the mapping? All right, so it's either represents a function or does not represent a function. So first, let's decide if it's a function. I'm just going to look at the x's. You see how there's only one arrow coming out of each x value? That means that it is a function. So I'm going to get rid of anything that says it's not a function. Okay, G and J are out. Now let's look. The mapping represents y as a function of x because each y value corresponds to exactly one x value. Now that's not true because this y value has two x's. Remember, I don't care about the y's when I'm determining the function. Only looking at the x's. Got to be this one. It's a function because each x value corresponds to exactly one y value. There's only one arrow coming out of each x. So my answer is H. All right. Which one represents a function? This is your vertical line test. You can put a vertical line through the graph and touch the graph in more than one place. See how I'm touching that curve here and here? It's not a function. There's lots of places where I can touch it twice. Not a function. This is not a function because a vertical line, I can draw another vertical line over and touch it infinitely many times. So this is not a function. I'm looking at the circle, right away I can see it's not a function because my vertical line will touch that circle more than one time. That's touching it on the top and the bottom twice. It's got to be this one. No matter where I put a vertical line, I'm only touching the curve of the graph one time. Vertical line, vertical line, vertical line, vertical line. No matter where I put my vertical line, I'm only going to touch this curve one time. This is a function. The answer is G. Number 10. An aquarium is being filled with water. The graph shows the height of the water over time. There's a time along bottom, height of the water. Which statement best describes the rate of change? Remember, rate of change is y over x. So let's find some clean points. There's one right here. My y value is 5 and my x value is 2. So 5 over 2, you put that in your calculator, it equals 2.5. So here it is right here, 2.5 inches per second. And no matter where I use my clean point, I could use this clean point right here. 10 goes with 4. That's still equal to 2.5. I could have used this clean point right here. And that is at that's not a clean point. Let's use this one. 20 over 8. If you do 20 over 8 in your calculator, it's still equal to, if I divide both of these by 4, it's still equal to 5 over 2, which is equal to 2.5. So it's always going to be a rate of 2.5. Number 11 says a tree in Dante's neighborhood grew 18 inches in the first 2 years. So notice we've got inches along the y-axis and years along the x-axis. So if the tree continues to grow at this rate, which best describes the growth rate of the tree? So we're trying to match 18 inches with 2 years. Here's 18, and it crosses right there at 1 year. We need 18 for 2. Not it. Here we've got straight up and down. At this level, we're not talking about undefined slopes right now. Probably not going to be this one, but if you'll notice 18 for 2, but you're supposed to have a box like this, not straight up and down. Okay, here's 18 matched with 2. 18 for 2, that is the 1. Let's just double check. If I go to the 2 and go straight up to the line, it's crossing right here just below the 72. That is not the 1. It's got to be G. It's pretty much just kind of a matching game. 18 for 2. Number 12, again, we've got 3 adults to be matched with 45 students. 3 adults, it looks like to me, the adults are along the y-axis and the children, the students are along the x. And that's because I've got smaller numbers here and bigger numbers here. So 3 has to be matched up with 45. And here, it's not. It's about 135, halfway between 120 and 150. So this is not the match. 3 has to be matched up with 45. Like halfway between 30. These are going by 15. Half of 15, half of 30 is 15, and 30, then 15 more would be 45. Here you've got 3 adults matched up with 45 students. That is a match. Here, 3 is matched up with 15. 3 adults to 15 students. Here we've got a flat line. That doesn't make any sense. It doesn't even touch the 3 anywhere. So it's got to be H. 13. We've got a 6-foot-tall man standing on the ground 3 feet away from point P. Here's point P. A line segment drawn from the top corner of the building to point P creates 2 similar triangles. So which proportion can be used to find H, the height of the building? We're looking for this height right here, the height of the building. So here's what I know. Okay, so the height over the distance to point P has to equal the height over the distance to point P. So I don't know the height of the building, but I know the distance to point P is 18 feet. And then the height of the man is 6 feet, and the distance to point P for him is 3. So you're looking for something that has H over 18 and 6 over 3. Look right here. H over 18 and 6 over 3. That is the one that has the correct proportion. And that is your answer submission for day 2.